I would like to welcome you to the live webcast, Is There Life Beyond Neptune? The Future of Multi-Collector ICP-MS. Under normal circumstances, we would have been able to meet you in person during the Goldschmidt conference in Hawaii. This year is different in many ways due to the COVID-19 pandemic and the related travel restrictions. We cannot meet you in person, and so Goldschmidt is now running virtually, and we also decided to connect with you the virtual way. So for that, we are using this live webcast from the Thermo Fisher site, Bremen in Germany. So before we start, let me just introduce my team, which is around me here. So from left to right, we have Nicholas Lloyd, Senior Manager, Product Line Management. We have Karin Persson, Senior Marcom Specialist. We have Grant Craig, who is Application Manager, Multi-Collector ICP-MS. We have Claudia Baumann, who is Product Marketing Manager. And we have Andreas Hilkert, who is Senior Manager, Vertical Market Geoscience. And myself, Hauke Vollstedt, I'm the Product Manager. So as said before, you can ask questions during this live webcast using the questions section of this video platform. For that, open just the control panel, upper right, and there's a questions section where you can ask questions. Andreas and Nick are keeping an eye on the questions that come in, and we try to answer as many as possible during a Q&A session after of our webcast here, which is about 15 minutes from now. Now I would like to come back to the question of this webcast, is there life beyond Neptune? And I would like to leave this answer to Claudia and Grant.
We are convinced there is life beyond Neptune. And actually, the answer to that question is sitting right behind us.
Coming soon from Thermo Fisher Scientific will be an all-new multi-collector ICP-MS, redesigned from the ground up to take advantage of the latest technologies and application developments. We want to take this opportunity to give the feedback that we've received from the MC-ICP-MS community during the development of this project and how that has influenced our design.
Claudia, one of the strongest reports we heard from the community is that they would like to see modifications of the collector system. Are you planning to change anything to this?
Yeah, that's a very good one, Hauke. Actually, we do. We have taken this on board and have redesigned the collector array as well as the detection system. The new design will bring all of the strengths of the current successful multi-collector technology. And we are working towards realizing a collector array that enables everyone to measure more isotope systems with total flexibility. So from lithium up to uranium and even beyond at different resolution settings, but without compromising the native dispersion of the mass analyzer. And not only that, we also are making the collector simpler. So obviously by implementing new hardware, but also by drawing on the very powerful software which is currently already implemented in the ultra high resolution IRMS.
Grant, what about the detection system? Do you plan to change anything to this?
Well, Hauke, we received a lot of feedback from the community on the detector system, and we listened to this, and we have decided here to implement quite a lot of changes to the detection system. What we saw, for example, was an ask for flexibility, for example, taking advantage of the latest amplifier technologies and also the latest applications which have been developed. Of course, we want to keep what's great about our current detection system and bring that forward into a new generation multi-collector ICP-MS. In terms of flexibility, which I've already just mentioned there, is very important. For example, we need to make sure that for the smallest ion beam and to the largest ion beam, all of these can be measured and achieve the ultimate precision and accuracy for both the smallest ion beams and the largest ion beams. We also want to do that with maintaining excellent linearity, and we also want to do this with minimizing the amount of corrections need to be applied, calibrations, etc., yields such as this. And any of those that do need to be applied, we want to be automated by the software as much as is feasibly possible. We also want to take advantage of some other features for the detection system, taking advantage of what people want in terms of high-end users. That is something we also need to take into consideration, and we'll do so here as well.
Thank you. Grant, another area that customers brought up was ease of use. How are you planning to tackle this?
One of the major areas for ease of use we want to tackle is with the software. So what we heard from a lot of people back was software was a key feature in software development. And so, for example, one area we want to look at here is workflows. So basically having the software in a structured manner to make it easy to follow and easy to use, reducing the amount of training it needs to be required to run a complex multi-collector ICP-MS, and also just making it easier for all its experienced users out there as well. Another important factor we can do in terms of ease of use is doing better integration. So integrating things such as third-party peripherals, such as desolvators, laser ablation systems, but also even first-party peripherals such as gas chromatography. Currently, the integration between these systems and current generation multi-collector ICP-MS is not fully optimized. This will be in the new platform with the ability to fully integrate these peripherals into the software, be controllable through them. This would be great for things such as compliance, metadata, tuning. All of this will become so much more easy. We also want to look at things such as automation, for example. So the idea that these processes can then be automated once they have been optimized, useful for very routine analysis, multi-user labs, all of this will be much more easy. The ability to switch between applications on the fly, this should all be implemented in the new design.
Thank you. One question, Claudia, that is related to this is, what about the ease of use with respect to the hardware?
So if you look at the plasma, for example, we are going to make lots of changes to various components within the ICP interface. Whether this is the torch injector setup or the RF generator. So as you might know, Thermo Scientific has a very strong ICP portfolio with the ICAP QNOVA series, ICP-MS, and the ICAP Pro ICP OES just recently launched. And what we are doing is we are taking all the good things that have been developed within this strong, huge portfolio in ICP technology, and we are taking this on board of the new instrument. So a newly designed torch, a newly designed injector, a newly designed RF generator. And besides the ICP interface, also the rest of the instrument will get many new features. And obviously, we're not going into the details here tonight. But be assured that the instrument with all these new features will be easy to maintain as well as easy to use.
Grant, we heard that the working height was an issue for lots of customers. Could you comment on that?
I suppose in an ideal world, we would have a benchtop multi-collector ICP-MS, shrink it down. But obviously, we all know in this community the technology that we're dealing with, and we know that means that we will end up with a fairly large, complex instrument, as you can see behind us. However, we are looking to reduce the platform size compared to the current generation multi-collector ICP-MS. One of those things being working height. We know with our current generation platform, the Neptune, there was people saying that we did need to be very tall to run the instrument efficiently, and this should not be the case with our new design. Another important thing about the size, for example, take into consideration though, is actually what I brought up earlier, which was the integration of third and first party peripherals, for example. These are something that are being developed all the time since the last generation platform. We want to make sure that the size and dimensions of the new instrument fits very well with these peripherals.
Thank you. Claudia, sensitivity is a critical point for isotoperation analysis. So many of our customers are aiming to measure lower and lower sample sizes and smaller samples.
Yeah, Hauke, that's true. And actually, if you want to ask me, are we doing something about this? The answer would be no. We are not going to compromise on sensitivity. As you said, we know that sensitivity is very important for multi-collector ICP-MS applications. And the current Thermo Scientific multi-collector ICP-MS is actually the most sensitive ICP on the market. And we have no intentions to change that.
Grant, there are many applications where polyatomic interferences need to be resolved from the isotope of interest. So classically, we would do this by just increasing the mass resolving power of the mass spec and measure on the interference-free shoulder of the peak. Are you planning to change anything to this concept?
Honestly, how can no? We're not planning on changing anything from this concept. As you mentioned, it's a very powerful technique ever since its introduction in high-resolution multi-collector ICP-MS. This is something we should absolutely retain in the new generation platform. If we consider, for example, elements such as iron, titanium, vanadium, chromium, with high resolution, all of these can be measured interference-free on plateaus, and this has been a powerful, well-implemented technique and is now being used more and more by the community, and we're not going to change that. If we even look at more difficult to separate interferences, such as, for example, hydrides, in our last generation multi-collector ICP-MS, we introduced a new technology to help separate these going to higher and higher resolutions. This is a feature that we will bring forward to the new multi-collector ICP-MS as well, and all of that good things will be retained. Obviously, there are still interferences which cannot be separated currently by high-resolution multi-collector ICP-MS, and approaches such as collision cells have been suggested as an alternative to separate such interferences. This is something we are actively working on, Thermo Fisher Scientific, and it's something we will report on shortly to the community.
Thank you. Claudia, many of our customers are very experienced users of multi-collector technology, especially from the geoscience community. However, there are certainly other users who have less experience, but still eager to perform isotope ratio analysis. How are you taking this into account?
Yeah, so I think most of this has to do with software. As Grant already pointed out, workflows is a key component here. So if software would enable the user to set up an isotope ratio measurement through a series of steps, guide them through all kinds of tuning, automation, calibration setups, then this would take out a lot of the complexity of multi-collector ICP-MS technology. And so it will also open up this powerful tool for more users, so less experienced users maybe within geosciences, but also beyond. And this is exactly what we are envisioning with all the new features that we are bringing in this powerful software package.
Grant, another aspect is reliability or service. So customers have reported reliability issues, for example, chillers with the RF generators and so on. Do you plan to change anything to this?
Reliability is something we take very seriously in Thermo Fisher Scientific, and of course this is something we aim to address with the new instrument. Of course, we cannot hope for an instrument which is such as complex as this. We cannot hope for that everything will go perfectly correct every single time. However, we have identified many areas that customers have mentioned with reliability, and these are areas we're actively pursuing very strongly to have as robust a platform as possible. This is something we will ensure.
Thank you, Grant. Thank you, Claudia. So now I would like to open up the question as a session for questions. So Nick, Andreas had a look into the questions which came in. You're still allowed to and welcome to ask questions during the Q&A session. But now let's see, Nick, what do you have for us?
Okay, so good evening. Looking at the chat question box just here. There's only one question in so far, so don't be shy. Go onto the question box and ask some questions there. The first question that came in is, it's going to be easier to use with the new software, but are you going to have full access to the manual control of the instrument? Is it going to be a black box at the end of this?
No, it shouldn't be a black box. We envision a future where, as I said, the instrument should be easy to use for routine customers. The instrument should be easy to use for people with little training. The instrument should be easy to use for industrial customers. The instrument should be easy to use for everyone. However, we know that many of our customers are academic customers, very experienced in multi-collector ICP-MS, and they will want full access for the instrument to do their analysis. New developments, new techniques. We know the community is constantly evolving, and that is something we will absolutely support with the new platform. We will make sure that it's open to you and that you can do what you want to do.
Very good. Okay, so at least another question's come in just here. Will your new software integrate with laser ablation software?
Yes, it will. So I'm sure people who are used to the Thermo Fisher Scientific ICAP QNOVA series will know, for example, there that we have very strong integration with some third-party laser ablation vendors with full integration between their software and ours, allowing communication between the two, very good triggering, for example, to make sure that sequences stay in sync with each other. So when you ablate, you can be confident that you collect the data. That is an approach that we're going to bring forward to the new multi-collector ICP-MS.
Excellent. Okay, another question coming in. The next question, can you say more about the potential for sensitivity with the new system?
As Claudia said earlier, we are going to absolutely ensure that we don't compromise on sensitivity compared to our current generation platform. We will ensure that we keep the same sensitivity or better than what we have previously. I think that's all what we should say.
Fair enough. Okay. Let's see if there's some more questions coming in just here. Let's see. So, question here. Collision cell technology is an exciting addition to the portfolio. What kind of mass bias stability do you think is involved in this? And will it be possible to use things like double spike correction with a collision cell? Or will it be purely a sample standard bracketing technique?
I think I can answer this question. Yes, we will be able to use double spike with any collision cell technology that will be developed by Thermo Fisher Scientific for multi-collector ICP-MS. That's something we will guarantee. But I'm not going to go into much more details here.
Certainly some questions about the timeline, when people would be able to see the system. So when can we come and make some tests on the new system?
I suppose what I'd say is we all know where the world is at the moment. I was supposed to be talking to you in Hawaii. We all were. And we should be going to the beach after this to maybe drink some cocktails, see some sun, for example, although it's a very nice sunny day here in Bremen. But we know where the world is at the moment. And so, yeah, demos, I think, at the point of time will be more restricted by world events than they will be at the moment by our availability to measure. What that means essentially is that as soon as practically possible, yes, we want people to come see the new instrument. We want people to demo with us. That's something we always encouraged with our current generation platform, and it's something we don't plan to stop. But yeah, currently no demos, but as soon as practically possible, absolutely.
Very good. Another question that came in, are you still moving cups with the new system?
As I said earlier when we talked about detection system, and as Claudia said earlier, we're going to keep the best things about our current generation multi-collector ICP-MS. One of those things we believe is moving the cups. Absolutely. This has always been our approach. We've moved the cups. I don't know since when, since before I was born, I think has been the approach of Thermo Fisher Scientific in terms of moving cups. So yeah, this is something absolutely we will retain in the new multi-collector ICP-MS.
Very good. So we mentioned more flexibility of application, and especially how will this improve measurement in laser ablation for radiogenic systems such as lutetium hafnium, but also some stable isotopes such as boron isotope ratio analysis.
So I suppose this real question here is, will the instrument have any advantages for measuring boron?
And also lutetium hafnium was also mentioned as well.
Oh, lutetium hafnium, okay.
So a real mixture there.
A real mixture, yeah. I'm trying to wonder who's answering this question. Yeah, so of course there will be many improvements. I said we've talked about software, for example, ease of use. This will apply to everything, for example. Both of these systems are quite commonly measured by laser ablation. We've talked about integration here for these systems. lutetium, hafnium, all these things. These are all there'll be many general improvements for these systems, for example. I think that's something we can state quite confidently. People will be happy with what we're planning on doing.
Okay, and let's see. Any more questions from the audience? There's certainly some questions about when we're planning to start selling it and finding out more information about it. We'll come back to the link where you can sign up to be the first to hear about that at the end of the question and answer. See if there are a few more questions coming in here. Which resistor ranges will be delivered with the system?
I'm sure everyone knows who's familiar with what we presented in many of the last Goldschmidts. We are a proud supporter at Thermo Fisher Scientific of 10 to the 13 ohm amplifier technologies. Again, this is something I wouldn't expect to change. As I said, we're not going to move away from that. So of course we will offer this technology. This is something we've been very proud of. So yes, that will continue. We'll obviously continue to support 10 to the 11 ohm amplifiers, which are the mainstay of multi-collector ICP-MS technology. And yeah, higher ohmic amplifiers are also available for certain niche systems, such as calcium, for example. These will always be available.
Okay, very good. See if there are some more questions. We still have time for a few. Okay, so one of them is, I've just purchased a Neptune XT. What impact does this have for me?
Hopefully they should have almost no impact for you. The Neptune XT is still a market-leading multi-collector ICP-MS. This is still a product we are very proud in, very invested in. This is something we will continue to support for many years to come. I've been a passionate user of the Neptune for coming up to over 8 years now, and yeah, this is still a great instrument and something we'll be supporting for a long years to come.
We're looking forward to that, indeed. Let's see. So another question here about the ICP and interface. Can you give us any details about the benefits of the interface and ICP?
As Claudia mentioned earlier, I said Thermo Fisher has a long history and a long trail of products in the ICP range. The ICAP-Q Nova series is a very important ICP range worldwide and well adopted in the community. And this is something we aim to continue on developing in terms of ICP technology. These ICP technologies that we've been developing will be incorporated in the new multi-collector ICP-MS and will be of benefit for many reasons.
Okay. We have time for maybe one or two last questions here. Say the penultimate question here. To be clear, is collision cell going to be the new standard, or is this going to be an option on a future instrument?
I suppose this is an opinion question, isn't it?
It is an opinion question.
I think we should answer this, but this is obviously what my opinion is. And my opinion is that collision reaction cell technology will be very important going forward in multi-collector ICP-MS. But personally, I don't see it being the standard for multi-collector ICP-MS. I see it being a powerful option for many applications, but I don't see it being the standard for multi-collector ICP-MS.
Okay, so one of the options available for researcher that needs those applications. Very good. Okay, I think we probably have the last question here. Can you tell us the color of the new instrument?
What do you call that? Sort of off-white, beige, maybe a little grey.
Light grey, I think, yeah.
Yeah, some darker highlights. Yeah, I think that's the colour we're going for.
Colour that we're going for, okay.
Yeah.
Very good. Okay, we're now going to hand back over to Hauke, and thank you very much for all the questions that we've enjoyed.
For your participation.
So now we're coming to the end of this live webcast. So thank you all very much for joining us this time. You can still connect with us during the rest of the week using the virtual exhibition hall. So for that, go to the Goldschmidt page and there's an icon for the exhibition hall. And then you can find a link to the Discord chat program and there you can connect to us using our channel. If you want to be the first one to get to know about the new multi-collector ICP-MS, please sign up to this webpage, so thermofisher.com/live-beyond-Neptune. With that, I would like to close the session. Thank you all again very much for joining us. Take care and goodbye.